are going to do a chemistry experiment. This is a simple and easy experiment. We'll be dealing with some fruits, so I hope you guys like fruits. So today we will be quantifying the amount of limonene present in various citrus fruits. The way to do it is to take the fruit using a grater, zest the fruit, and then you will be taking a methanol extract of the zest, and you will be using the GC to run this. GC stands for gas chromatography. GC instrument to quantify the amount of limonene present in that particular citrus fruit. Now the thing to note is the amount of limonene present in these citrus fruits depends on a number of parameters. So the amount of limonene varies with the type of fruit you are using, from orange to grapefruit. It depends on the season it was grown. It depends on the way it was stored. So when we do the experiment with different fruits, you should be getting different results. Now you may be thinking, okay, what exactly is limonene? So limonene, it's a D-limonene that is a commonly occurring and naturally available product, is very useful compound. It's used as a fragrance, it's used as a flavoring, it's used as a cleaning product, it's used as a solvent, it's used in insecticides. Now, this is the structure of D-limonene. It's a type of terpene. Now, you may be wondering, what's a terpene? Terpenes are a class of natural products which are biosynthesized by the assembly of isoprene units. Now, here, this is an isoprene unit. It's a 5-carbon moiety, 1, 2, 3, 4, 5. Now, when you assemble these isoprene units, you get terpenes. There's monoterpenes, there's diterpenes, and so on. So a monoterpene would be an assembly of 2 isoprene units, and a diterpene would be an assembly of 3 isoprene units. Now if you look at the structure of D-limonene, again you can see that it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 carbons. So, and isoprene, as I said earlier, is a 5-carbon unit. That makes D-limonene an assembly of 2 isoprene units, aka it's a monoterpenoid. Now if you look here, you can see how it is basically assembled. You can see 2 isoprene units here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 2 isoprene units assembled to form the D-limonene. Now in this lab, the experiment will give you the time it takes for the limonene to show up on the in the GC experiment, and it will also give you the area under the curve. Now the area is the concentration term here. You will be provided with a calibration curve, a standard curve. You can use the standard curve to calculate the amount of limonene present in your particular citrus fruit. I started with the experiment, and you will learn more about the GC and more about the calibration curve as we are doing the experiment. Now remember again, when you do the initial zesting, make sure you don't take any white part. All you need is the outer colored part. The white part will just add mass to your actual zest, but it won't add any limonene. The white part has very limited amount of limonene. Most of the limonene is present in the outer part. So let's get started.
All right, so first we need to obtain 1 gram of rind, and we will need to do this for each of the citrus fruits. We'll start with the grapefruit first. Before I obtain 1 gram of the rind, I'm going to go weigh this beaker so that we can subtract that from the mass of the rind plus the beaker. First, we'll zero out the balance, just as you guys know from doing this in lab every week. All right, now that it's zeroed and we have all 3 of the doors closed, which is the important part, you can open it, place the beaker on the balance, and then close the door again. So as you see, we've got 100.06 grams. I will go write that down now. All right, so now we will begin to zest the grapefruit to hopefully obtain about 1 gram of the rind. So this will probably be a bit of a process. I'll have to weigh it after grading some and see how close we are to 1 gram. Proof that I do know how to cook. All right, that looks like it's about 1 gram. The important thing is that I've only taken the outer surface or the rind.
She will be right back after weighing the rind.
So it turns out that I have grossly overestimated what 1 gram is. Instead, I have graded 4 grams. So I'm going to remove approximately 3/4 of this zest. And just... we'll try it again. So now I have obtained exactly 1 gram of the grapefruit rind. Didn't have to be exactly 1 gram, but just so turned out that way. All right, and now I will grate the remainder of the fruits. Pipette is calibrated to 1 milliliter, as you can see right here. So we will need to pipette twice. Since we're using the same solvent over and over, I'm not changing the pipette tip, but if we were to be changing solvents or touching the sample at all, we would need to change the pipette tip. Filtering our methanolic suspension of these citrus peels through a cotton plug, which will be going through a pasture pipette. So first, we need to plug the cotton down into this narrow part. We will do so with another longer pipette and just kind of stick it there until it settles and doesn't move. From there, we'll place the Tygon tubing, which is slit open, right over the pipette. And then we will clamp it to the ring stand. But of course, in order to filter anything, we need to have a separate container. So we will just use separate vials for now, and then we will just pipette the methanolic solution into our gas chromatography vials. So now it is important to properly position our filtration apparatus directly over the vial. I have already grabbed 4 different clean pasture pipettes. So first, we will start with the grapefruit. I'm going to grab the permanent marker. So we will label each of these new vials. All right, situate it directly under our filtration apparatus, and we will start with the grapefruit first. Before we pipette our methanolic solution, we will first somewhat grind and kind of mash the citrus peel to allow for the maximum extraction of limonene. look at this, folks. Look at that nice green solution. All right, so now that we have all of our solutions prepared, we will go ahead and assemble our samples for GC analysis. So this small tube right here is called the insert. So the reason why we place these inserts into the gas chromatography vials is so that we can actually reuse these vials. The inserts are one use only and they're disposables. We will be disposing of them after making our samples. All right, let's start with the grapefruit. I'll come a little closer to the camera.
That's full. That's good enough.
All right. Next, we need to actually seal these vials. So we'll place the lid on the top using the crimper, not for your hair, but for the vials. Bad joke, I know. We will.
You'll hear the, yeah.
And now it is sealed.
Label it as
We'll label it grapefruit. We'll put GR for grapefruit.
Injector, the syringe that actually pulls up the sample is inside this tower, and it's a 5 microliter syringe. Most of our samples are just usually 1 to 2 microliters that go on the column. This actually spins around. Samples are in a sample holder or a carousel in a capped vial that goes into the machine here, and the syringe actually in the carousel moves such that it pulls up the solution that we're analyzing and then injects it into the injector, which is right on top of here. That's where the samples enter the column. And the column is actually in an oven right here. And as you can see, this is a capillary column, very thin column that is attached to the injector. The sample comes in, it goes through the column, and it exits into the detector, which is right there. The actual detector is within this metal box here, and it is a thermal TCD, thermal conductivity detector. And so there's actually two gases passing over the detector. When your sample comes through, it changes the potential across the detector, and that's how it's you get a response.
Okay, now that we have all of our samples in the instrument and method set up, we're going to go ahead and start analyzing these samples. Just patiently waiting. And as you can see here, we have our first gas chromatograph. This is what they look like. But don't worry, we will be uploading these documents to Blackboard so that you can use the data in your experiment. Alright, so now that we've collected all of our data from the gas chromatography experiments, I would just like to clarify a few things for you and walk you through a sample calculation so that you can figure out what you need to do for your post-lab calculations. So first of all, here is the calibration curve that you'll be using. You'll be using this calibration curve to solve for X, which will be your concentration in milligrams per milliliter of limonene. And don't worry, this calibration curve will be uploaded to Blackboard in the folder for the limonene lab. So as you saw on the calibration curve, the equation is y equals 9,760.5x minus 25,807. So right away you can just set that equation equal to the area under the curve, which is the integration that you'll find in the report for the peak that has a retention time of about 1.8 minutes. And again, all of these limonene peaks will be labeled for you on the gas chromatographs to help you more. So already setting that equal to the area under the curve, let's just say, for example, that you get 1,000 microvolts seconds for your area under the curve. So right away we would set 1,000 equal to your equation for the graph. And then again, moving over the 25,807 to the left side of the equation, so you have to add it. You can set that equal to 9,760.5x. Then you're finally dividing 1,000 plus 25,807 by 9,760.5. You will obtain a value for x of 2.746 milligrams per milliliter of limonene. So 1,000 isn't the area under the curve for any of these graphs, but I just wanted to give you guys a sample calculation so you can know what to do for your report.